This will be the last video of Chapter 9. It's on limiting and excess reactants. So when two substances react, very rarely do they react in a perfect ratio so that they both run out at the exact same time. What typically happens is one of them runs out first, and then when that one runs out, the reaction stops, and then there's a little bit of the other one left over. Now the one that runs out first is called the limiting reactant. That's the substance that is completely used up first in a reaction, and it limits the amount of product formed. So when the limiting reactant runs out, when one of the two reactants runs out, the reaction's done. The reaction can't run unless both reactants are present. Now that leaves the other one left over, and we call that the excess reactant. That's the substance that is not completely used up in a reaction. There's a little bit left over. Now how do you decide which is which? Well, you got to do a little bit of stoichiometry to figure it out. So what you end up doing is you end up using the amount of each reactant that you have, and then you take both of those numbers, do a little bit of stoichiometry, and find out how much product could be formed from each reactant. Then whichever reactant gives you a lesser amount, that's how much will truly be formed. And the reactant that gave you that amount is the limiting reactant. So write that down. Probably doesn't mean a lot at this point. I'll do an example and then come back and maybe watch this again, and it'll make a little bit more sense. But before we do the math examples, I'm going to show you some, just diagrams, some pictures to help drive the point home. So in this example, it says which reactant is the limiter and which is the excess. Draw the final products after the reaction is complete. So the first thing we have to do is balance it, but in this case it's already balanced. So you can see here that it's a 1:3 reaction, mole ratio. It's a 1:3 mole ratio how they react. So for every one of these, 3 of these react. And then when that happens, 2 of these are formed. So what I'm going to do is, for every one of these that I cross out, I have to cross out 3 of these. And when I do that, when one of these and 3 of these disappear, it makes 2 of these things. Now, at this point, all of my hydrogen is gone, so the reaction is over. It's done. We can't form any more NH3 because there's no more hydrogens. So at this point, we'd say hydrogen is the limiting reactant because it has run out. Nitrogen is in excess, but it's important that I don't forget that because this is left over, it's still there. So this box becomes this box after the reaction. We can't forget that there's still some of this left over. So when this reaction's done, we won't actually have pure ammonia. We're going to have ammonia mixed in with a little bit of nitrogen. So I want you to do the same thing I just did in that slide. Pause this. I believe this is in your notes. And draw this and figure out which one is the limiter and which one is in excess. Now the white is hydrogen, the red is oxygen, and then you can see water over here. Now to do this, it's a 2-to-1 ratio. So for every 2 of these, I have to cross out 1 of these. And when I do that, it makes 2 water. So let's keep doing that until one of them runs out. 2 hydrogens for every 1 oxygen. That makes 2 more waters. 2 hydrogens for every 1 oxygen. That makes 2 more waters. 2 hydrogens for every oxygen, because it's a 2-to-1 ratio. That makes 2 more waters. Let's keep going. 2 hydrogens for every 1 oxygen. That's 2 more waters. Now at this point I have used up every hydrogen. So I'd say hydrogen is my limiting reactant. I am just done with this computer trying to write with this. That was supposed to be LIM. Let's see if it can handle it this time. Super slow. So the hydrogen's my limiting, and then I would say oxygen is my excess reactant. So there is a little bit of oxygen left over, so it is important that we take those excess and we draw them over here. Remember that, we'll erase all that. Remember that that box becomes this box. The hydrogen no longer exists. It turned into water. The oxygen mostly doesn't exist anymore other than the 2 molecules that are left in excess. Okay, now here's how we do an actual math problem. We're moving on. It says if 38 grams of silicon reacts with 38 grams of oxygen, how many grams of silicon dioxide will be formed? And then which reactant is the limiter, which one's in excess? So to start this, as always, we balance it first. And it's actually already balanced. Hey, what do you know? That's always convenient. There's 2 oxygen, 1 silicon, 1 silicon. Now, I have to set up 2 ladders for this problem. I have to say, okay, if I start with 38 grams of this, how much would that make of this? If I start out with 38 grams of this, how much would that make of this? So let's set those up, and I'll explain a little bit more how this works. So 38 grams of silicon, 38 grams of oxygen, and then I'm going to bring grams of silicon down, moles of silicon. Let's go here. I'm just going to pause the video and write all this in for you. Okay, so I got it written in. I tried to write it slower so that it wasn't quite so laggy and choppy. Now what I did is I brought grams of silicon down, went to moles, moles to moles, then moles to grams. I'll assume that you know how to do that at this point. And notice how I went from silicon to grams of silicon dioxide. Same thing here, but I start with oxygen. Grams of oxygen to moles, moles to moles of silicon dioxide here. So moles of oxygen to moles of silicon dioxide, then moles to grams. So the moles get the 1 whenever they're with grams. In this case, all the mole ratios, it's all a 1-to-1 mole ratio. And then I have to put in the molar mass of silicon, which is 28.086. O2 is 31.998. And then silicon dioxide is basically 31.998 plus 28.086. And then that is 60.084. Nice thing about doing these problems is that once you solve the molar mass of that, whatever you're going to, you don't have to do it for each ladder because it's going to be the same. The end of each ladder should always be the same when you're doing these problems because you're going to the same thing. Now at this point, when you do this calculation, this is the important concept to understand. When I say 38 grams of silicon goes in, how many grams of silicon dioxide goes out? You're assuming when you do this reaction that you have more than enough oxygen for all of this to react. Same thing when you do this problem. When you do this problem, you're assuming that you have an excess amount of silicon so that all of this oxygen reacts. So in both of these problems, you're assuming that you have an excess of the other one. But we know that that's not true. We know that one of them is going to run out first. We just don't know which one. So we're going to solve for this. I'll actually pause and do the calculations here. There we go. After calculating both ladders, we end up getting these 2 numbers. So what this means is that if I have 38 grams of silicon and I had more than enough oxygen, this 38 grams would produce 81 grams of silicon dioxide. Now if I had 38 grams of oxygen and then more than enough silicon for it to react with, this 38 grams is capable of producing 71 grams of silicon dioxide. So now we look at this and we say, okay, my oxygen can only produce 71 grams of silicon dioxide. So when I go back up to this assumption, when I say, okay, if I have 38 grams of this, of silicon, it could produce 81 grams as long as I had an excess of O2, or plenty of it. But I don't have plenty of it. I only have enough oxygen to make 71 grams. So this doesn't exist. This is not my answer. Silicon cannot make 81 grams in this scenario because it only has enough oxygen to make 71 grams. So that's how we solve for this. So we would say that oxygen is my limiter, and then silicon is in excess. So silicon is in excess, oxygen is my limiter, and then how much could be formed? 71 grams, and it's rounded to 2 sig figs because that is the number of sig figs I was originally given. See if you can apply that and solve this one on your own, and then I'll solve it next. Okay, so step 1, balance the reaction. To balance it, we need a 2 here, and we need a 2 here. The next step is we need to set up our ladder. I'm going to set that up off the video, and then I'll come back. So I've got it all written in now, or at least the units. So what you do is you take your two numbers, 17.3 grams of hydrogen, and you start with that. Then you take 63.1 grams of oxygen, and you start with that. And you might be tempted to be like, okay, well, obviously this is 63 grams. There's way more of this than there is hydrogen, so this is definitely going to be my excess. This is the one that runs out first. But don't be so quick to just make that assumption, because it may or may not be correct. So let's go through, put in all our ones for the moles that need the ones. Our mole ratio, 2 waters for every 2 hydrogen, 2 waters for 1 oxygen. Notice here this is a 2 to 1 mole ratio. So this is a 2 to 2 mole ratio, so it's really hard to compare these original numbers because it already is going to get a little bit complicated. Now the molar mass of water is 18.0148 if you added it up. So again, I'm hoping you had done this already, and then I want you to check to see what is different. If it is, or if it's all the same as me so far, then you're on the right track. Then 1.007 is hydrogen, so double that, 2.014. Oxygen, the mass of that is 31.998, because there's 2 of them. Got to double it, don't forget to double. So let's do the math here. So I did the math, this divided by this times 18, because 2 over 2 cancels out. You get 155. 63.1 divided by 31.998 times 2 times 18.0148, you get 71.1 grams. So the last question is, which is the limiter and which reactant is in excess? Well, we know that this is the amount of water that can form. It's always the smaller number. So this number is not the answer. So we know that as this reacts, as these two substances react, oxygen will run out first. And when it runs out, the reaction will stop, and at that point only 71 grams will have formed. So oxygen, O2 would be my limiter. Which one is in excess? It would be H2. And then how much water is formed? This question, the answer to that is this. So for these questions, for these types of problems, you'll typically have 3 answers. And make sure you show your work for both ladders. These are worth a lot of points, and make sure you show all of your work so you earn all of the points on them. I will continue to practice these and keep working on your stoichiometry.